So we're here at Open Sauce, a big adult science fair where a bunch of really smart people show off all the stuff they're working on. Today we're here with
Mike Stewart, the Curious Mark YouTube channel. We collect and restore old electronics, all sorts of different things. Stuff that was used on the space program, stuff from aircraft, old test equipment, basically anything that catches our interest.
And how old is old?
1950s, 1960s is mostly what we have represented today.
Crazy. And then what is this box we're sitting in front of here?
So this is a coupling data unit. It's from an Apollo lunar module. It was mounted on the back wall, sort of right behind the astronauts.
Was this specific one in space?
This one has not been to space.
Right.
This was a development unit, but same configuration as the ones that flew. If you're familiar with the program alarms that happened on Apollo 11, this is the box that screwed up and overloaded the computer.
Right.
So what I'm working on is tricking this into thinking it's actually in a lunar module and then replicating that issue on the original hardware so I can better understand it.
And can you talk a little bit about what that process is like? I'm assuming there's not really well-written documentation on exactly how to interact with it.
To the contrary.
Oh, interesting.
I got complete schematics for it from the National Archives.
Wow.
So it comes with, we found basically complete specifications for
Incredible.
all of the connections that we need to make to it, all the voltages I need to apply. I have very, very detailed information about how I'm supposed to interface with it.
But still, I'm sure even as somebody experienced, digesting this stuff and figuring out how this coordinates into what signals go down what wires, and how do I talk to it with a modern computer.
Yeah, so it's taken me about 3 years to put all of this together.
Wow. And do you have to, I would assume, all the interface hardware, that's something you had to develop and build all on your own?
So I had to build this connector breakout plate. This is a power supply that I designed to generate all the voltages that I need to run everything.
Incredible.
This is an Apollo guidance computer running in an FPGA with all of its I/O circuitry.
Very cool. And would you say you know this thing inside out, upside down, what every single wire and every voltage does? That's crazy.
I know a lot about this box.
Awesome. And then while you were digging into this, what's the hardest problem you had to solve, whether engineering, just problem solving or otherwise, in chasing towards what you're trying to figure out?
So I am a software engineer by trade. I've taught myself electrical stuff. The hardest bit for me was like the mechanical bits here.
And why do these even exist if it's a software problem that failed?
So this box is basically an analog to digital converter that is calculating the angles on these shafts. These are putting out sine waves, basically, that describe the angles.
Right.
This box is responsible for taking those sine waves and translating them into a digital angle, which it sends to the Apollo guidance computer.
And would these be like a articulating piece on the ship? Is that the idea?
Basically, yeah. So these would be mounted on the rendezvous radar antenna, so you can see exactly where the antenna is pointed.
Oh, very cool.
So it was in the process of translating these sine waves into a digital angle that broke down. And so in order for me to make this box break down in the same way, I have to have something that looks exactly like the original angle sensors.
And have you replicated that failure?
I have, yes.
And do you understand it fully?
No. I'm working on it, but it's very complicated.
Very cool. And where can everybody find more about this project and all the other incredible stuff you and your pals are working on?
Curious Mark YouTube channel.
Awesome. Thank you so much for taking the time to explain that to us. That is absolutely insane.
Yeah, thank you.